Question 11. Which types of intermolecular force exist between methane, methanol, and methyl chloride molecules? So methane is a non-polar molecule, and non-polar molecules, they have London dispersion forces. Okay. So option A, London dispersion forces only. Yes. Option B, London dispersion forces, hydrogen bonding. No. Option C, London dispersion forces. Yes. Option D, London dispersion forces, hydrogen bonding. No. So we have option A and C. Let's move to methanol. So we know methanol should have hydrogen bonding in addition to London dispersion forces and dipole-dipole. So let's read option A. London dispersion forces, hydrogen bonding, dipole-dipole. Yes. Let's go to option C. London dispersion forces, dipole-dipole. No. So that leaves us option A as the answer. Let's move to methyl chloride, which is a polar molecule. And yes, it should have London dispersion forces as well as dipole-dipole forces. Hence, correct answer is option A. Question 12. What is a molecular geometry and hybridization of the numbered atoms in the molecule shown below? So the first one they have asked around nitrogen atoms. So let's work out how many domains are there. So we can see 1, 2, and 3 domains because lone pair is included as a domain. So we have 3 domains around nitrogen. So that means hybridization will be sp2. The lone pair repels more than the bond pairs. So the molecular geometry will be bent here. And number 2, so that carbon is attached to a hydrogen. So we have 1, 2, and 3 domains. So hence geometry will be trigonal planar and hybridization will be sp2. So we don't have any lone pair. Number 3, so we have 1 and 2 domains. So hybridization will be sp and geometry will be linear. So let's start reading these statements. So A, sp2 and bent, yes. For carbon, sp2 trigonal planar, yes. And number 3, carbon, sp and linear. So A is the correct answer. Question 13. How many sigma and pi bonds are present in the molecule below? So let's display this molecule. So we have carbon, and each carbon is attached to cyanide, and cyanide is C triple bond N, C triple bond N, C triple bond N, and C triple bond N. So 2 carbon, they have 3 bonds each, so we need to have another bond there, so carbon-carbon double bond. So let's start working the pi bonds. So each cyanide has 2 pi bonds, so there will be 8 pi bonds because of cyanide. And there's a 1 pi bond between carbon and carbon. So total we will have 9 pi bonds. So if we look at the options, 5 in A, 5, B, 5, C, 9. So C is the correct answer. But let's count how many sigma bonds we have there. So there are 4 sigma bonds in cyanides, and there are 4 sigma bonds between carbon to cyanide, and there's a 1 sigma bond between carbon-carbon. So total 9 sigma bonds. So in this molecule we have 9 sigma bonds and 9 pi bonds. Hence the correct answer is C. Question 14. Which statements are correct for alloys? So the first statement is the mixture of metallic cations of different sizes increases the strength of non-directional metallic bonding, making the alloy harder than parent metals. True. Number 2, the different sizes of atoms in alloys prevent the layers of metallic cations sliding over each other. Yes. So the layer gets distorted and it prevents the movement of sliding of layers over each other. Number 3, adding carbon to iron produce an alloy that is stronger than pure iron. Yes, so it is steel, and hence all 3 statements they are correct. So option D is the correct answer. Question 15. What are the signs of delta H and delta S for this reaction that is non-spontaneous at high temperature and spontaneous at low temperature? So let's look at the options. So option A, delta H is positive, so is a endothermic reaction, and delta S is positive, so there's an increase in entropy. So endothermic plus signs here, minus and plus will give us minus. So we want it to be non-spontaneous. So at high temperature, this factor will be bigger. So it will be spontaneous, but we're looking for non-spontaneous at high temperature. Hence is not the correct answer. Let's move to option B. So is a exothermic, so delta H is minus, and there's a decrease in entropy, so minus and minus give us plus. And we want this reaction to be spontaneous at low temperature. So we want this factor to be smaller, and that is possible at low temperature. When temperature will be low, so T delta S will be lower, and delta H, which is negative, will be bigger. Hence B is the correct answer. Well, let's look at option C. So exothermic minus, minus and plus minus. So this reaction will be spontaneous at all temperature because delta G will be negative. So now let's look at the D now. So we have plus, delta H is positive, minus and minus give us a positive, positive. So overall delta G will be positive, so non-spontaneous at all temperature. Hence answer B is the correct answer. Question 16. This question can be answered in 2 ways, either to use Hess cycle or to manipulate the equations. I'll be using the manipulating method. So if we look in these 3 equations given, and in the last equation we have ethene, or ethene is on the product side, but we want ethene on the reactant side. So if we flip the equation, so the sign of delta H will become minus, so minus Z kilojoule. So we want CF4 on the product side. We have 1 mole of that. So if I multiply this equation with 2, and I need to multiply delta H with 2 as well, and we need 4 HF. The first equation has HF, and there are 2 moles of HF. And if I multiply that equation with 2 as well, so I need to multiply delta H with 2 as well. So if we add these 3 equations together, so we'll get the overall equation. So we need to add delta H as well. So delta H will be equal to minus 2x plus minus 2y plus minus z. So if I solve this, I will have 2x minus 2y minus z. So let's look at the options. So option D has minus 2x minus 2y minus z. So D is the correct answer. Question 17. Which of the diagrams represent the Maxwell-Boltzmann distribution of kinetic energy of the molecules of the same sample of gas at 2 temperatures, T1 and T2? T1 is bigger than T2. So what we're looking for, peak will lower down and shift to the right. So let's look at option A. Peak has shifted to the right, but peak has moved up. So no, we're looking for the peak will lower down and shift to the right. So B, T1, yes, the peak has lowered down and a shift to the right. So B is the correct answer. Question 18. This question is about enthalpy change. So delta H. And we know delta H is equal to Q over N. and Q is equal to mc delta T. So the mass of solution will be 50 because density of water is 1. So 50 times by 4.18, and temperature change will be 28. There's no need to convert into Kelvin because change in temperature will be the same. So that will be in joules. If we divide that with 1000, so we'll have kilojoule. So the next step is to divide this with the moles. So the moles of ammonium chloride will be N will be equal to M over molar mass. So M is 107 divided by 53.5. That will give us 2 as the answer. So let's look for the options. So straight away I can get rid of A. There's no need to convert into Kelvin, and same way I can get rid of C. There's no need to convert temperature. There's a decrease in temperature, so that suggests this is an endothermic reaction. Endothermic. So we're looking for a positive sign, so we can get rid of B because it's a negative sign. So D is the correct answer. You can have 50 times by 4.18 times by 28 divided by number of moles times by 1000 to have a kilojoule or mole. Question 19. The non-catalyzed decomposition of hydrogen peroxide was monitored giving the dotted line. So the dotted line graph represents non-catalyzed reaction. Which curve represents the catalyzed reaction if performed the same temperature using the same concentration? So same temperature, same concentration. So same concentration means we're looking for the same volume of oxygen produced, but it will be much quicker. The rate of reaction will be faster. Catalyst provides alternative pathway, and that pathway has lower activation energy. So A is not right because the volume of oxygen produced is doubled. B seems right. Same volume of oxygen is produced and the rate of reaction is a lot quicker. Let's look at C. C is not right because the rate of reaction is slower compared to the dotted line, is less steeper, so C is not right. D is not right because half of the volume of oxygen is produced, so B is the correct answer. Question 20. So we have been given a graph of 1 over T against ln K, and what does the slope of the line represent? So we know minus EA over R is equal to gradient. So the slope is the gradient, which is delta y over delta x. So let's look at the options. So A, minus EA over R. So straight away I will go with A. A is the correct answer. So minus EA over R is equal to gradient. And the gradient is delta y over delta x. So hence A is the correct answer.